Howdy folks, I'm Keith Bowen, and this is Hard Rock University. We're up here at Mojave 1 again. The wind is a little less than last time, which is a lot better for the audio track. We're going to do something a little different this time. Now, we've already done the preliminary sampling survey to establish we have a small vein, it's generally low grade, and it's got some high grade pockets. Now what I need to do is try and get some material, as in, 500 to 1,000 pounds of material, maybe not all from here, but to do some extraction testing on the various equipment. I have something that requires about 200 pounds just to charge it. So I need some volume, I need the best material I can get, and I need to get it fast. This is about 7 hours from my house. So 7 hours out here to the area, another hour and a half to the mine itself. Obviously taking samples, sending them off for assay, waiting a month, getting results back is not going to be very helpful. So I'm going to do speed prospecting. What this means is we're going to be actually doing some rough testing of the samples in real time in the field to determine what's the best that we can access right now, right here, and get some more of it, and then maintain real-time grade control, basically. So, right here, we are not trying to do the kind of representative sampling you would normally try and do for an ore body. We're trying to get some ore to process. It means we're trying to find the best stuff we can, the quickest we can, and get the most of it we can. I'm doing what they call high grading. Right in here, we have what looks to be a heavy mineralized little veinlet. See, I've chipped some out already. We're going to test this and see what it runs. We've got, this is more hematite here, more limonite there, and I'm using a very handy tool. It's an illuminated loop. I can actually look at the rock in real time, underground, without trying to do all this stuff. They come in very handy. And this looks more like wall rock, this looks more like high-grade vein. So that's what I'm going to try and get out here. Got my tarp down here. Hold it up against with my boot. Okay, that's enough for a sample right now. Then we'll sample the other wall, and if these are good, we'll keep digging. If not, we'll move the ladder into the other stope and do some sampling there. This is why speed prospecting is so important. We're adjusting our attack as we go. As Chris up there running the camera knows, the first casualty of battle is the battle plan. So you need to get intelligence as quickly as possible to adjust your tactics as efficiently as possible. So we're starting with, here's one of our samples. First thing I'm going to do, screening it down to 1/4 inch mesh. Now, this is not a representative sample. As a matter of fact, it'll probably tend to high grade it. We are not getting absolute numbers. For this, we want relative numbers. What's the best that we can get? Doesn't matter what that number is. Just that it's the best. So, that's the 1/4 inch plus. And now we go to about a 20 or 30 mesh screen. Then just dump the stuff in there. When I get home, it'll be dry, it'll be crushed, it'll get blended, it'll get split, and then we'll be able to get an actual real number. I'm not losing the value of this sample as an absolute number, but I need to find out what's the best material right now. So, I've done all that. Looks like about half of what a usual sample would be. So now I can take this, this already has jet dry in it, and pan this down. Anyhow, so this is our third sample we've done now, I believe. And yes, what we have here is a result. This is so far the best results, but you can see that's a clear result. It's the best so far, so we know we're getting into a better zone to mine out than where we were before. And we can focus on that. We still got a couple more samples before we decide on what spot we're going to mine stuff out of. With this particular ore, I would say that's better than an ounce to the ton. However, it's not the bulk sample crashed. It's the fines from predominantly the cracks between the rocks as we mined it out, and therefore this could be heavily enriched. So we can't be nearly as confident as if we had an assay or if we had crushed and split this. But there it is right there. Now what I do is take it, put it right back in to this, and there's some here, put that in there, stir it around. That's the sample. Put this on top, let that settle, and then we'll go ahead and dump the solids back into that bucket. By the time I get it crushed and split, we should have done very little to affect the final results from that sample. But we now have a good idea. Of these 3 buckets, I know that one's the best at this point. We got 2 more to go. Let's see what happens. And now for the last part, we've had these settling for a little bit. Go ahead and pour off the excess water. So in case the material in the cracks is higher grade than the rest of the rock, it's now back in the sample. It can be crushed up and split with the rest of the sample, and this bucket has the same amount of gold it started with before I did the test. If I took and did the test and then threw it somewhere else, I could be lowering the grade on this. So by doing that, I don't lose any information. We got 350, 400 pounds of material, something like that. Brought it back here, crushed it through the RC46, and did some testing with the hydromatic. Very useful. I think mainly I've got to deal with crystal lock and mineral liberation issues. I have a lot of testing of concentrates to do. In terms of recovering clean, free milling gold, I've got probably 8 to 10% of the total now. Recovered 0.18 grams of pretty clean gold, and you know, a bit of arsenopyrite concentrates, which will have to be assayed, and then we'll have to assay tailings and everything else. The initial tests on my table were not very good, but some of the tests also indicated it wasn't free gold. I mean, 3/4 of the gold still wasn't free. So that indicates to me that we got a real mineral liberation issue with this ore, which is not terribly surprising. It's probably in solid solution in the arsenopyrite. So speed prospecting helped us out here. Now let's go to the Dreamer Prime and take a look at it again, but this time with the laboratory assays to go along with it. We're at a place we call the Dreamer Prime because the Dreamer mine is just on the other side of that hill. Now it's near Arivaca, Arizona. It's on our claims. In lesson 24, improved hand panning microfine gold. This was where I got the sample. Now I'd like to get some more rock to do some production testing. I'd like to have about 1/2 ton of it, if possible. But what's the good stuff? I'm going to call the zones starting from left to right. Zone 1 appears to be hanging wall. Zone 2, fault gouge. Zone 3 looks kind of like entrained wall rock. Zone 4, fault gouge. Zone 5, I'll call it stringer vein. This may be part of Zone 5, but I've separated this to Zone 6. Zone 7 is foot wall. Zone 6, the bucket is marked 1/3 ounce per ton, because that's what I got out of here before. So here's the zone after stripping and mining. This was the low-grade waste. This was the high-grade material. You can see the very sharp delineation there. You can also see that the material tends to be in cracks. That's very common, and that's why you sometimes get some pretty high-grade concentrating just by screening. But this appears to be the richest material here, and down there should have 5 to 10 buckets full, which is adequate for my needs. And quite frankly, it's been a long weekend. It's kind of warm, and I'm an old geezer. So we're going to call it quits, load everything up, and get the hell out of here. Happy prospecting, and keep it safe out there.